Hello dear students, welcome back. So today we will be solving another problem from JAM MS 2025. This is problem number 11, and here we are given a function f from R to R, which is defined as fx equals to x plus pi cos x, and we have to find the number of real solutions of the equation fx equals 0. Now one thing that immediately comes up to all of our mind, right, is to make the plot, to make the graphs and get some idea about the nature of the functions. So for that, you note carefully that this function is taking values in so we have x plus pi cos x. We can write this as pi cos x equal to minus x. Here pi cos x will take values in pi to minus pi, right? So this will be the upper bound, say, and this is like the lower bound minus pi. So on 0, x equals 0, pi cos x will take value pi, and this is how it will look. So then if you move towards this side, it will gradually be something like, say, if this is pi, then this will be minus pi. Similar for this side, and the y equals minus x line is something like this. So now the thing is, if this is y equal to x, now there are many things that can happen. So firstly, it may completely pass above this portion and don't even touch this line. Next, it can cut this line, and it can pass through this curve more than once, and in that case we will have two solutions on this side and one solution on here, so total 3. Or otherwise it may also go like this there. In that case we will have only one solution. So we have to carefully determine, using some tricks and some code analysis, that what is the correct situation. So this is the roadmap. We will rewrite the problem and see there are some conditions for any real root, and we will use sign checks to locate root and use basic ideas from calculus like basic monotonicity properties and this intermediate value theorems, things like them, for solving. Okay, so first we rewrite fx equal to 0 as this. Now note that if you have mod x, then that is pi mod cos x less than equal to pi. So what does that mean? So any real solution must lie in this interval minus pi to pi. So this is how we are now constraining the possible domain of solution from R to minus pi to pi. Now we do a quick sign check. So we will check sign at minus pi, pi and 0, which are the three most obvious places. So at minus pi it is negative, which is minus 2 pi. At pi it is 0, because if you check at pi, this is pi and this is also pi into minus 1. So both are equal to pi. So f of pi equals 0, which gives us already a root, and f of 0 is pi, which is positive. So the signs are negative, positive, 0. That means there is a sign change here, and that means there will be some root, at least one root here, and there is another root at x equal to pi. So there is at least one root in minus pi to 0, and x equal to pi is a root. So already we know there is at least two roots. Now you have to specifically get to know what is the situation or what is the exact number of solution. So now I think from the graph you can already think that since this is a solution at pi, so at x equal to pi, y equal to minus x takes the value y equal to minus pi, sorry for that, yes. So at x equal to pi, y is minus pi, and pi cos x is equal to minus pi. So both are minus pi. That from the graph already gives us the solution that there must be another root lying in between 0 to pi. Just to be double sure, we will do some more checks and then we will conclude. So one immediate thing that we get from the graph, of course, and from derivative as well, is that f prime x is 1 minus pi sin x, which implies on minus pi to 0, as sin x is negative, this is positive. In fact, this is greater than 1, so f is strictly increasing on minus pi to 0. And as f of minus pi is negative, which is less than f of 0, that is positive, and it is strictly increasing, so that means from minus pi to 0, it is strictly increasing and there is only one root. So strict increase makes it unique, and there is exactly one root in minus pi to 0. Okay, now what about the other range? So we will now see for the range 0 to pi. Already pi is a root. We will see whether there is any intermediate root or not. Now if you think for x plus pi cos y, like cos of x here is greater than 0 for x less than pi by 2 greater than 0. So in this whole range, fx is positive value because both components are positive. Now that means there is no chance of any root lying in 0 to pi by 2. So there must be any root, if they are there, must be lying in the interval pi by 2 comma pi. Now here from some elementary calculations you can check. For example, if you take these 2 points, for example 5 pi by 6 and pi by 2, you can check at pi by 2 it is also positive, and at 5 pi by 6 it is negative. But again, I think this is already clear, because since there is one root at pi, from the graph it should be clear that there is another root somewhere which is greater than pi by 2, which is greater than pi by 2, and that actually can be shown if you take further derivatives and apply intermediate value theorems. But again, that is not needed for the purpose of jam, because here you are more concerned about getting the correct solution, and that is already obtained as long as you have that there is one root on the negative side and there is a root at pi. It automatically helps you conclude that if you are careful with your drawing. Still, I have mentioned this just for being double sure. At x equal to 5 pi by 6, you can check f of 5 pi by 6 is negative. So this gives us a solution between pi by 2 and 5 pi by 6. So there is one solution lying between them, and in the domain the function is also monotonic, so there will be no other solutions. And between 5 pi by 6 and pi, you can show that it is throughout negative, and it increases from a negative value to 0. So the solution is at the edge pi. That is the third solution. So that means in conclusion there are two roots in 0 to pi, and there is one root in minus pi to 0, and combining them, total roots in minus pi to pi is 3. So the correct answer is option C, 3. And this is just a plot for making sure everything is okay. This is a plot of the function fx, and here you can see there are two solutions, and the trick in the problem is one may miss out just by graphical plots these two roots, or this root specifically, they might miss out. But if we are little more careful, we can very clearly conclude that this is the case and there is no other root, which is very clear from the monotonic properties of y equal to minus x and pi cos x. in the domains minus pi to 0, 0 to pi. So that was all about this solution. Now to conclude this video, I just thought about mentioning a brain puzzle where you take any a positive and define f a, which is x plus a cos x, and try to determine how the number of real roots change as a varies. So please give it a try. You will need similar methods for obtaining the solution. With that note, I will say thank you. So this is the end. See you in the next video.